a box of mass 440 kilograms is placed on a rough inclined plane of slope 15 degrees and a coefficient of friction of 0.25. A rope is attached to the box, and the direction of the rope makes an angle of 30 degrees with the surface of the plane. If the tension in the rope is T newtons, find the limiting values of T for which the box will remain in equilibrium. Okay, to do this, you've got to consider two cases. Case 1 is when the limiting friction of the point of slipping downwards. So if we draw a diagram here, as the box is going to slip downwards, the friction limiting value F is equal to UR will be acting in this direction. Here we have our rope attached at 30 degrees and our slope at 15 degrees. Our weight acting downwards, 440 G newtons, and our normal reaction here are being perpendicular to the slope. If we mark on I and J, and now if we resolve in the J direction, i.e. in this direction, we're going to have R plus this one here, which is going to be T sine 30, going in that direction, and downwards we were going to have this one here, which makes an angle of 15 degrees. It's always the same as this angle here, of 440 G cos 15 degrees, and that will be equal to 0. They'll balance each other out because there's no movement in that direction. Making R the subject, R will be equal to 440 G cos 15 minus T sine 30. Now you're sort of advised really to leave these like this and then just deal with the sine and cos at the end of the problem. Right, revolving in the I direction, so in this direction, we're going to have this one here, which is going to be T cos of 30 degrees. We're going to have mu R as well, so plus mu R. And then acting in this direction, we're going to have 440 G sine 15. So that has to be subtracted, and that will be equal to 0 because the box is in equilibrium. It's at the point of slipping downwards. Right, now replacing the mu with 0.25 and the R with this, 440 G cos 15 minus T sine 30. Don't forget now we still have the minus 440 G sine 15 degrees is equal to 0. Now it looks a little bit horrendous, but we'll just work with it. So we're going to have T cos 30 plus 110 G cos 15 minus 0.25 T sine 30 minus 440 G sine 15 is equal to 0. Again, I would leave these sine and cos exactly as they are. So just writing that line out again. Right, we've got here T cos 30 and a 0.5 T sine 30. So we take the T out, we're going to have cos 30 minus 0.25 sine 30. And then taking this over to the other side, we're going to have 440 G sine 15 minus 110 G cos 15. Right, so making T the subject, so we're going to have T is equal to 440 G sine 15 minus 110 G cos 15 divided by all of this, which is cos 30 minus 0.25 sine of 30 degrees. Now, if we now use the fraction button on our calculator, making sure we're in degrees, we can now do this problem quite easy. So putting this value into our calculator, it's going to give T around 100.8868 newtons. Right, now considering the second case, so limiting friction at the point of moving upwards. So if we're going to move upwards, the friction now acts downwards or along the plane in this direction, i.e. against I. So, but the diagram is exactly the same. Okay, so resolving vertically will be exactly the same as the previous case. In the J direction will be R plus T sine 30 minus 440 G cos 15 is equal to 0. And making the R the subject, we get 440 G cos 15 minus T sine 30 like before. Now, if we're resolving in the I direction, i.e. this way, we're going to have T cos 30 degrees from this one here. But acting in the other direction, we're going to have 440g sine 15 and minus mu r from the friction. And doing the same sort of thing we did before, we'll now substitute that in here and making mu 0.25. We're going to have 0.25 times 440g cos 15 minus t sine 30 degrees. Again, I advise you to leave the sine and cos as they are. So we've got t cos 30 minus 440g sine 15 minus 110g cos 15. Now, minus times a minus will become a plus. That's quite important, and that would be a very likely place to make a mistake if you're not careful. 0.25t sine 30 degrees is equal to 0. So taking that line and writing it out here. Collecting together the terms in t, so we're going to have t brackets cos 30 plus 0.25 sine 30 degrees, and then taking the other things to the other side, we're going to have 440g sine 15 plus 110g cos 15. And then we're going to make t the subject, so get 440g sine 15 plus 110g cos 15 divided by all of this, which is going to be cos 30 plus 0.25 sine 30. Now, using the fraction button on a calculator, if we're careful, we can change a couple of the signs in the previous calculation. If not, type it in again. Be very, very careful. Taking g as 9.8, you're going to get 2,176.83 newtons, which means that t, the limiting value of t, would have to be between 110.8, greater than that, and less than 2,176.8 newtons for the box to remain in equilibrium. I hope you've understood, and I thank you very much for watching.